My name is Amanda Sheffield, and I'm from Scripps Institution of Oceanography in San Diego, and I'm a Regional Drought Information Coordinator for NIDIS here in California, Nevada. This bi-monthly webinar series is designed to provide the region with timely information on current drought status and associated impacts, as well as a preview of developing climatic events, which is important now as we've moved out of drought this year, so we're thinking about more the what's upcoming versus what we've seen previously. This webinar is being recorded, and all its presentation slides and a 2-page summary flyer will be available on drought.gov later this week. So just a little background again on the National Integrated Drought Information System. NIDIS works to provide a better understanding of how and why drought affects society, the economy, and the environment, with the goal to improve accessibility, dissemination, and use of early warning information for drought risk management. And we're working to do this by building off a network of regional drought early warning systems to create a national drought early warning system. How we do this is utilizing new and existing partner networks of federal, tribal, state, local, and academic partners. And here in California, Nevada, for example, we have NOAA partners with the California Nevada Applications Program, which is a NOAA RESA program, the National Weather Service, the Western Regional Climate Center, and more. We build off here from the original California DEWS and as well as the Governor Sandoval's Nevada Drought Forum in 2015. We have a strategic plan that's nearly complete for the drought early warning system to keep us moving forward. And in June, we had our first annual coordination workshop to bring together the two states and how to mutually benefit both states and what we've been seeing and researching and monitoring in both. With that, we'll get to today's webinar. The first update will be the normal drought and climate status update by Julie Kalansky, who's the program manager for CNAP. Then we're going to add a groundwater update as well as Jordan Goodrich, who is also a CNAP postdoc and is working with the USGS thinking about groundwater in California and Nevada. Andrea Baer from the National Weather Service is joining us to do the drought and climate outlook. And then we'll also have a drought scenario from the 4th California Climate Change Assessment from Dan Can, who is the CNAP PI and has been working closely for not only this assessment, but also past assessments for the California Climate Change Assessment. So with that, I'm going to pass it over to our first speaker, who's Julie Kalansky.
Thanks, Amanda. So on today's climate update, I'll be talking about 3 main themes. One is the current weather climate, which has recently been hot, the water status, which currently is lots, and fire potential, which is right now is high. So as this is a drought update, I wanted to show the Drought Monitor, and as you can see, there's regions in coastal Southern California and southern and southeastern Nevada that are abnormally dry to moderate drought. It's 23% of the region, and 5% of the region is in moderate drought. This is from the West-Wide Drought Tracker, and I should mention before I go on, for all the slides, you can get the information and the figures by the websites that are shown in the bottom right-hand corner of the screen. And so this is showing PDSI, which is a proxy for drought, and it takes into account both temperature and precipitation. And this shows something that's similar to the Drought Monitor, where you see coastal Southern California with a negative PDSI, as well as southern and southeastern Nevada. And this was just for June 2017, I should mention. So there are a couple slides that look like this, and what this is showing is the region that we're talking about today, so California and Nevada, and then on the right side of the screen, it's a figure for most of the West. These come from the Great Basin dashboard. And so this summer, as probably many of you have experienced, has been pretty warm, and what we see in California, Nevada, and throughout much of the West, it's about 2 to 6 degrees warmer throughout the West so far. And this has been over the last 30 days. So I was actually curious about this as I was putting this together, is what's the relative humidity been recently? And this is over the last 30 days from Climate Engine. And my own personal sweat index made me actually think it was higher than this. But when I looked it up, it shows that although we are here down in San Diego, that it is slightly above normal. Much of the region in California and Nevada is pretty close to what normal minimum relative humidity is for this time of year. Now thinking about precipitation, and precipitation for this time of year, I know it shows most of California and a lot of Nevada being relatively dry, but this is just a really dry time of year, so small changes can make a big change in terms of percentage. And so this is percentage of average precipitation. The area to really zoom in on is this area in the circle, which is what the North American summer monsoon impacts. And so early in July, when the monsoon starts in this region, there wasn't much moisture, but recently in the past couple of days, we've started to see it pick up. And you can see here in the southern part of Clark County and parts of southeast California, it's been between 400 and 8% of normal over the last 30 days. Looking at the next figure, so this is just over the last 7 days, which is when most of that precipitation has come in. And so there's been this recent increase in monsoon moisture in southeast Nevada and in general with the North American summer monsoon this year. Now moving on towards water, these are the reservoirs for the Big 12 in California. Most of the reservoirs are above average for this time of year, and some of them are pretty close to full capacity. For example, San Luis Reservoir, Milton Lake. You notice that Lake Oroville is a bit lower, and that they're keeping up those levels as they repair the spillway. This is a figure that's been shown on several of these updates. It's a combination of reservoirs and snowpack in California. And so there's a lot going on, but let's go over it. So if you look at the blue, that's the average reservoir totals for the reservoir shown as red dots in the figure on the right. The red line is the current status of water in these reservoirs. And then the gray shaded area is the normal amount of water in the snowpack. And the orange line is the reservoir plus snowpack for California. And as we can see that this was updated just this past weekend through July 20th, or just last week. And this year we had obviously quite substantial snowpack, but that most of that is melted off because the snowpack and the reservoir lines have met up with each other. For comparison, Mike Dedinger, who makes these figures, put on indications of past wet years. So for example, 1983 is the asterisk, and our snowpack never got quite as high as 1983, or actually 2011, but the melt-off appeared to be a bit quicker this year. So moving on, so looking at Lake Tahoe levels for Nevada, as much water comes from this area. The red line is the natural rim of the lake, and this goes back from 2011 to 2017 throughout this current year. And you can see how it shows the historic drought previously, and then came up a bit last year, and then over this past year has increased quite substantially, and its water levels are still very high in Lake Tahoe. Next is looking at storage for Lake Powell and Lake Mead, as that has impacts on water supply, particularly for southern Nevada and for southern California. So Lake Powell this year, or currently, is about 64% of storage, and it's 1.65 million acre feet more in storage this year than last year at this time. Lake Mead, on the other hand, is only at 38% of capacity, and it is slightly above where it was this time last year. It's at 590,000 acre feet more this year as compared to last year. So this I took straight from the California Nevada River Forecast Center's Twitter feed, but I thought it was a really interesting point and summarizes in some ways how wet of a winter it was and how much snowpack and then the runoff. So for more than 6 months, 193 straight days, at least one of the flood forecasts within this region was at monitor stage or above, and it shows some of the peak days during the year. So for example, on January 12th of this year, 42 of the 98 flood forecast points were all above that critical threshold of a normal condition. And in February 11th, it was 50 of the 98. So it just talks about how wet of a winter it was and how big of a snowpack we had that has slowly melted off over the past several months. So now moving on to fire. So this is from CAL FIRE, and the red dots show the current ongoing fires, whereas the black ones show the fires that are under control. And the data here, again, it's from CAL FIRE, and it shows the fires that have been reported and the acres burned in this calendar year thus far relative to last year. You can see currently we're about 3 times, or over 3 times more than where we were last year at this point, and well above the average for over the past 5 years. And then also too, because this is just from CAL FIRE, the last line is combining CAL FIRE and U.S. Forest Service statistics, which increase both the fires and acres. And so this touches on what was in the last webinar, that oftentimes years after drought are actually pretty severe fire years, which is something similar to what we're seeing in Nevada. And so this is from USGS that's put together these maps. And so currently you can see the green arrows are the fires that are currently still burning. And the size of the triangle indicates the size of the fire. And the fires here in the northern part are quite large and been pretty severe and still going. The red squares are all previous fires this year, either human caused or unknown caused, and then the black squares are previous fires from this year that were naturally caused. And total so far this year, Nevada's had 384 fires and with over 800,000 acres burned. And this is just looking at the departure from average greenness. And so this is an indication of how green it is relative to past years. And as we can see that in some of the areas where it is red, it's a lot drier and there's generally less green. And so potentially these are areas that have more fire risk. Along these lines, these are the dead fuel moisture for the country that the U.S. Forest Service puts together. And the upper left-hand are the small flashy fuels, which, as you can see in much of California, Nevada, these are pretty high. The medium fuels, which the diameter of these fuels are 1 to 3 inches, not obviously somewhere between these flashy fuels and fuels that take longer to burn. Again, much of Nevada has pretty high fuels, as do the large 1,000-hour fuel moisture. And so this is just showing that throughout the California, Nevada region, and in particular, much of Nevada, especially for the medium fuels, there is high dead fuel moisture this year. And so it puts the region at risk. So this is a bit more weather related, but this is a 7-day significant fire potential. So it's in essence a 7-day fire risk forecast. And what we're seeing right now is that large parts of Northern California, Northern Nevada have high risk, and this L is an indication of lightning. So lightning's been forecasted for this region today, and so it puts it at higher risk. The base map below is the risk without these additional triggers. Just a brief summary of the climate for the region, and it's been, as I said, abnormally dry to moderate. We have abnormally dry to moderate drought conditions in coastal Southern California and Southern Nevada. It's been a warmer than normal start to the summer. The monsoon precipitation was slow to start in early July, but has picked up over the last 10 days. Although most of the snow is gone and there's lots of wet water in the reservoirs, the Lake Mead, however, is only at 38% of normal or capacity, though this is higher than it was last year. Thus far, it has been an intense wildfire season, and there still remain large amounts of fuels. Thank you. I'll turn it back over to Amanda.
I forgot to mention we're saving all questions for the end, so go ahead and type in your questions if you had them along the way, and we'll get to them there. Next up is going to be Jordan Goodrich to give us a bit of a short update on groundwater.
So thank you, Amanda. My name is Jordan Goodrich. I'm a postdoc researcher here at Scripps with the CNAP team. And today I'm just going to give a very brief kind of snapshot of groundwater status, in particular with respect to California, where obviously a big question being asked is how much benefit did we see from this year's particularly wet season with respect to groundwater recharge following the historic drought. So I just want to start by pointing out a couple of the primary resources that people can turn to for information and data on groundwater. So for California, obviously, the Department of Water Resources has a great website. Also USGS, Office of Groundwater. So for both of these resources, you can look through an interactive map where you can zoom in and out, find individual well locations, create figures on the fly, and potentially even download figures or actual data from these sites, either from one particular monitoring well, or if you want the whole archive, you can download that as well. In addition, you can look through various summary maps and reports or bulletins that are published online periodically by these sources as well. So these are a good place to start. Obviously, there are a lot of other resources out there as well. So I'm going to talk through a couple of figures just to give a brief kind of update here. These were maps that are upkept by the Department of Water Resources Groundwater Information Center. And so they do a pretty good job of keeping these up to date. These were last updated last month. So I'll start with the left-hand figure here. What we're looking at are individual groundwater well locations that are used to monitor groundwater levels. So here, this figure is showing the relative groundwater level from this past month compared to that 1 year ago. So green here indicates that levels have increased where you get water recharge, and red and orange indicate where locations where we're still getting actual declines in groundwater levels. So in general, when you look at this map, this basically you see what you would expect to see after a particularly wet year, where the vast majority of these points are green, indicating that we get some degree of water, groundwater recharge. But if you look a little closer, you start to see this spatial pattern wherein there are a few more red and orange points, particularly in the southern Central Valley and out down into Southern California. So it's important to note that groundwater stores take much longer to recharge than obviously surface water reservoirs. And so the time that it takes to do this depends on various factors that vary with region. So these might include soil type, bedrock contours, surface land use, and surface water hydrology. And so, for example, we know that large portions of the southern Central Valley here have more what we call confining layers or semi-confining layers. So in other words, inputting water at the surface there will only percolate so far into the ground before it runs into an impermeable layer. So adding more water here does very little to recharge groundwater in those regions. So if we move to the right-hand figure, the story gets a bit more grim. So this is the same map, but comparing groundwater levels from last month to that 5 years ago. And this is where we really see the impact of the continued pumping of groundwater particularly during the drought, where we're seeing mostly red points here, indicating that despite having one of the wettest years on record in California, that's done very little to alleviate the deficits that we've racked up from pumping groundwater here. So the other aspect I wanted to touch on briefly was snowpack. So Julie showed a figure just before where in addition to having a particularly wet season, we also saw a particularly large snowpack built up in the Sierras. And this is important because as that snowpack melts, this represents another critical mode of groundwater recharge for a lot of the Central Valley. So in particular, if we look here in the sort of southern Central Valley, these points represent surface water monitoring sites where color is denoting the percent of long-term average for this month to date. So this is just updated for July 23rd. So what we're seeing here is that flow in these rivers is well above average in many of these locations. And that's important for the southern Central Valley in particular because a lot of these rivers are what we call losing streams, where as it flows downstream, surface water is being lost to the groundwater system, and that's a critical form of recharge for these aquifers in that region. And so, of course, this impact will continue to fade as we move further into summer and fall, further from the snowpack melting season. So despite the fact that this wet year's positive effect may continue somewhat into the short term, so we may see some increase continue on, this will not be nearly enough to alleviate the large deficits that we've racked up over the years, in particular with the most recent drought. So on that very positive note, I think I'll hand it back to Amanda. Thanks.
All right, thanks, Jordan. At this time now, we're going to move over to Andrea Baer, who's going to give us the outlook.
Okay, thanks, Amanda. Good morning, everyone. I'm happy to be with you this morning. I'm going to go through a little bit about where we are with ENSO, or the El Niño La Niña situation, and then talk a little bit about the climate and drought outlooks that come from our Climate Prediction Center in the National Weather Service. And I wanted to call attention to this climate.gov website down below. About twice a month, our ENSO forecasters back at the Climate Prediction Center, they post an ENSO blog, and they give lots of good information and great graphics and easy to understand material, and that's about twice a month. So check with that every now and then to get some good information on the latest with El Niño and La Niña. The map I have posted here would be the sea surface temperature anomalies that are for June of 2017. And as you can see, this is the box that we really look at to determine whether or not we are in an El Niño or La Niña or in neutral conditions. So we call it Niño 3.4. And as you can see, basically just some warmer than normal anomalies over that portion of the Pacific Ocean. And I'll go through the current conditions with other parts of that in just a moment. So I'm going to give you the summary up front and at the end. Right now, our ENSO alert system is not active, and that means we're in an ENSO neutral phase. So we are not in La Niña conditions or El Niño conditions right now. And basically those equatorial sea surface temperatures in that box area where I just showed you are really just slightly above average in that area, but in other areas they're near average to above average. Really not a lot of indication to show us that that El Niño is going to actually form. So right now, our official forecasts are favoring ENSO neutral to remain through the Northern Hemisphere winter, so through the season of February, March, and April of 2018. I wanted to show this because it gives a nice indication of how we define El Nino or La Nina episodes. And this is a little history back about 12.5 years. And here we are with the last full season that we had. So my arrow down here at the 0.5. And that was the official sea surface temperature anomaly that occurred in that box I showed you in that first slide, that Niño 3.4 area. And that's the very minimum threshold that we look for to say that we're starting to move into an El Nino episode. But what we really need is 5 seasons. So we would need to keep that 0.5 or greater for about 5 seasons in order for this to be an El Nino episode. And we just really don't see that in the models or in the current conditions as likely going to happen. So to give you a good indication of that, this blue shaded area right here shows that weaker La Nina episode that we were in last fall and the very beginning of winter this year. So really it met the minimum definition. It was very weak, but because it overlapped 5 different seasons starting in July, August, September, and extending through November, December, and then January of 2017. So that's why that was considered a La Nina event. But these values, these numbers are quite weak. So, and what we're looking for El Nino is 0.5 or above, and then for La Nina, negative 0.5 or below. So moving on to the sea surface temperature departures throughout the entire tropical Pacific for the last month. The equatorial sea surface temperatures were above average across the western portion of the tropical Pacific and then the east central Pacific, but really near average in the eastern Pacific. So not very impressive in the eastern Pacific for the last 4 weeks, that is. I know earlier in the spring it was quite impressive over off the coast of South America, the Peru area, but not so much the last 4 weeks. So these are the various regions of El Nino. They've basically chopped up that equatorial Pacific area. And again, this dark box shows the area we're really looking for in the United States to define whether we're in an El Nino or La Nina situation. And these are weekly sea surface temperature departures. So for the past week, that critical area we look at is above average, but it's really not that impressive. And this is that area also you can see back from August 2016 to current where we've been. So this shows that weak La Nina episode we were in and then getting out of that and now moving into what looks like for a little while we could be moving towards El Nino, but really is just very barely on the border for sea surface temperatures and of late slightly cooling off towards these last 2 weeks of July. So one thing we look at is the upper ocean heat content, and you can see these negative subsurface temperature anomalies that were occurring during that last La Nina episode. But then as we get into this calendar year, really starting to warm up and again, looking a little more El Nino-ish, but doesn't look like it's actually going to happen. Another thing that we look at for the definition of moving into El Nino, we really do need the atmosphere to respond to those warmer than average waters in that Niño 3.4 area. And we're just not seeing that. The atmosphere remains very neutral conditions. We're not seeing the convection or the dateline that we want to see, and not seeing those westerly wind anomalies that we want to see. So really the atmosphere is not responding at all to that slight warming in the east, or excuse me, in the central Pacific. This is a look at the model forecasts, and this is put together with the International Research Institute and then our Climate Prediction Center. And they're definitely favoring ENSO neutral, which would be these green bars right here. really through the entire period, through March, April, May of 2018. That's the most favored category. But I do want to call your attention to the red bars. There is still a chance that the atmosphere could kick in a little bit, but we're just not as confident about that as we are. It just seems like the models are trending definitely towards keeping this an ENSO neutral event. But we are keeping our eyes on the possibility, since those bars do make the possibility of El Nino slightly more enhanced than a normal year than climatology would suggest. Here's another look at the models. Our Climate Prediction Center and climate forecasters in general, they survey over 30 models when they are looking at whether or not we're moving into an El Nino or a La Nina event. And so most of the models, they're surveying both dynamical models and statistical models. And most of the models, if you look at the averages, so this big thick yellow line, keeps us below that 0.5 threshold to say that we're before we can even talk about moving into El Nino. Definitely keeping both the statistical and the dynamical averages below that threshold. And just to head off any questions about our climate forecast system, which is our actual model in NOAA, in the National Weather Service, does sort of indicate that we may see some cooling as we move into the latter part of fall and into winter. We're not really considering that very much in the forecast right now. It's just something they're watching because it's just one model. It's a model that happens to be initialized daily, so you really don't want to look at daily model runs. It's model runs that have information that are over weeks and then at least a month that are more valuable for seasonal forecasting. So we are keeping an eye on that, but it is nothing anybody's very excited about right now, about that slight cooling. I think it just, you know, shows a little more evidence that we're probably not thinking as highly of developing El Nino. Okay, so I wanted to show you a little bit of a different way to view our seasonal outlooks, and I hope this works okay. I'm going to bring over from my other screen our Climate Prediction Center's webpage. And if you look on any of our outlooks, the 6 to 10 day outlook, the 8 to 14 day outlook, the 1 month outlook, or the 3 month outlook, next to each of those, you'll see this word interactive. And so at the end of May, they released these maps. They've always been available for a few years for the 6 to 10 and 8 to 14 day outlook, but they're now available for our monthly outlook and our 3 month outlook. So say you were interested in the 8 to 14 day outlook temperatures. So if you click on that, you can make it a little darker if you want to. The nice thing about this is I can pick whatever city. So let's pick Sacramento, California, and it zooms in pretty fast and quick. I like to zoom it out a little bit myself, but basically what it tells you is it shows you these nice pie charts, which I really like. So we're really, we have quite a bit of confidence. So we're highly favoring above normal temperatures for that 8 to 14 day period coming up. So do expect things to be warm, and we are pretty confident about that. That pie chart, the higher that pie chart goes, the more confidence that forecaster is about his or her forecast. It'll also show you the precipitation forecast. In this case, we're really not favoring a forecast. We're not favoring above, below, or normal for precipitation. So there's really nothing that's giving us an indication of above or below normal precipitation. But it's kind of nice because you can get the normals in here and click on any area of the country. So I really like this this new map and just wanted to show you all that as a different way to view our maps, a little more friendly. So for the ones that I picked, I just happened to pick Los Angeles, California, but it nicely shows all of the contour areas. So this is precipitation. Unfortunately, I hate to say this, but yeah, we don't have a favorite outcome. There was nothing in the tools for the seasonal outlook for the longer range forecasters to really hang their hat on or have any confidence in precipitation that was either above, below, or near normal. So anything can go. So pretty much not really a forecast for California, Nevada for the next season of August, September, and October. And then moving on to the temperature outlooks. Slightly favoring above average temperatures. Again, I just picked LA, but you can actually see this whole area. So slightly favoring above average temperatures for the August, September, October season. And then again, it gives you your normal, so you have something to compare to for the time of year. So wanted to show you those. I like those a lot better than the old maps personally, so play around with that, and hopefully you'll like them as well. And then moving on, lastly to our seasonal drought outlook. The Climate Prediction Center is holding steady with drought persisting in those areas that have such a long-term deficit in the southern portion of California, in the southeast portion of California. Not really much in Nevada, but holding on to those for the next 3 months. So that's the 3-month drought outlook. And then I'll end with where I started. Again, looks like ENSO neutral conditions are going to be with us through that end of, well, mid winter, so February, March, April of 2018. And so check back and see the forecast next month, but hopefully you'll like that new tool I showed you. So with that, I think I am finished, Amanda. Thank you.
Okay, thanks, Andrea, and thanks for showing the new tools. It's exciting to see the new visualizations. Okay.
Yeah, I'm pleased.
We're going to ahead and pass it then back to our last presenter, which will be Dan Kay, and also from Scripps, and we'll be showing a scenario of 20-year drought in Northern California.
Hi, everyone. This is Dan. Amanda asked me to present some results that have emerged in our work with the California Fourth Climate Change Assessment, in this case involving a scenario of multi-year drought over the northern part of the state, which we were asked to provide to study teams in the assessment. So a few guiding questions that this effort was framed by, which, by the way, this work performed by David Pierce, Laurel DeHaan here at Scripps, along with myself. Those questions: how extreme would befit such a drought scenario? Can we identify a drought within climate change simulations that has reasonable characteristics as far as magnitude and so forth? And finally, what are the hydrologic expressions? So I've got some slides here I'm going to breeze through to illustrate how we constructed the scenario, and finally what it shows. Just briefly, the fourth assessment for California is the latest in a series of assessment that were instigated by a governor's executive order under the Schwarzenegger administration back in 2005. This assessment was rolled out last spring, and our group here at Scripps has been involved with the so-called scenario development, which is providing downscale climate information, sea level scenarios. Julie Kalansky talked earlier to the group, and she was involved in the sea level projections. along with these downscale climate simulations, we've also provided this 20-year drought scenario, which takes two forms. One in the relatively early 21st century, and one in the middle part of the 21st century. We are using a set of climate models as our raw material here, and the models that were developed for the fourth assessment were identified using a selection procedure that the California Department of Resources sponsored with its Climate Change Technical Advisory Committee, under which 10 GCMs, Global Climate Model platforms, were identified as producing results that seem to be suitable for California water resource variability and change applications. So just as background, in terms of the climate change that is anticipated by climate models, here's an envelope actually of 32 GCMs, which includes the 10 aforementioned, under two different emission scenarios. The blue spaghetti or envelope here is one in which it's called RCP 4.5, 4.5 watts per square meter out of energy balance by the end of the 21st century. One that's considered to be somewhat moderate by way of greenhouse gas emissions and the growth of CO2 concentrations and other greenhouse gases in the atmosphere. The pink envelope, which is partly obscured by the blue one, is the higher emissions family, so-called RCP 8.5, 8.5 watts per square meter out of balance. The models are run retrospectively rather in addition to prospectively. So there's a historical set of simulations, which is represented by the gray envelope. The dark lines here are the median. Actually, I think they're the average. I correct myself there, of all of the 32 simulations. You can see that the different emission scenarios start to diverge in about 2050, when the amount of greenhouse gases that accumulate start to really have an impact on the surface energy balance and the resultant warming of the planet. This, by the way, is California statewide temperatures at the annual level for what you might consider afternoon, that is daily Tmax levels. Roughly 4 degrees Fahrenheit of warming by mid-century, and then so it goes, increasing through the end of the century. In map form, early, mid, and late century for the winter season DJF shown at top, and June, July, August shown at the bottom. And not a real surprise that much of the state warms substantially. The coastal areas warm less than the interior, but these mountainous regions that are the water catchments for the state are generally warming quite a bit as we go forward. And of course, that plays a role in the impacts of dryness. That is, just lack of precipitation is not the only part of the story here in looking at a drought that might play out in the future. Here's the change in annual precipitation towards the end of the century for the RCP 4.5 and 8.5 family of simulations. So this is a median level. The bluish shades represent areas that get wetter, and the degree of wetness here ranges from about 5 to 10%, I guess I'd say. The yellowish shading are areas that under the model simulations median become drier. So in general, the northern part of the state probably gets a little bit wetter on average over this 30-year period. Well, the southern part of the state gets somewhat drier, and of course, there's texture within that either getting wetter or getting drier. That was pretty simplified. But on to the drought scenario. So we wanted to consult historical variation and dry episodes to essentially inform the drought scenario that we constructed for the future. This happens to be Climate Tracker Sierra Nevada and North Central region precipitation combined. The Climate Tracker, a tool that John Abotsoglu and Kelly Redmond put together a few years back. You can consult with that on the Western Regional Climate Center page. We actually used a form of this data that was detrended in order to sort of quantify the dryness. If you look at this time series, of course, characteristically for the West and California in particular, there's a lot of variability. But it turns out that the period from the late teens through the late 30s is the driest 20-year episode in the observed record. And if you look at that using a CDF, a probability distribution in cumulative form, where the combined North Central and Sierra is the trace here in gray in the middle, the North Central being the blue one and the Sierra Nevada being the black one. You find that the median is a little over 43 inches, and the lowest 20-year period observed is about 35 inches. That lowest amount in percent is about 86% of the long-term of the median. So that gives you an idea of what a really extreme dry period over 20 years historically has produced. So here's 10 GCMs, and don't worry too much about the details here, but we consulted the same region of areally average precipitation from the downscaled version of these GCMs and identified various dry spells that occurred in the record. I'm not going to go into a lot of detail here because of time limitations, but it turns out that one of these models, the so-called HADGEM2ES, run under the RCP 8.5 scenario, produced a dry spell in mid-century that equates to about 78% of the historical median of that model's precipitation over the pre-climate change historical period. And that's the episode that we ended up selecting as our 20-year drought scenario. It's somewhat more intense than what we saw historically in the observed record, but not that much more. And of course, one of the virtues of these climate change simulations is that they provide a day-by-day simulation of weather, including temperature and precipitation and so on, that is dynamically consistent. So we can call upon that episode as a scenario of dryness as it plays out in the future. In our case, what we did, because it was requested by the resources agency that we look at an earlier rather than mid-21st century dry episode, we essentially adjusted the temperature in that particular scenario and translated it so that it occurred over the period between 2023 and 2042. And the results of that particular adjustment, which then were used to drive a hydrological model simulation, are shown in the slide here. The dry period is delineated by the dotted lines in this particular graph, and the different frames on this graphic represent temperature, precipitation, soil moisture from the VIC hydrological model in early summer, June 1, snow water equivalent taken at the traditional April 1st, essentially late spring time marker, and then finally annual runoff. In order to cast the hydrological components here in comparison to the other simulations, we've also plotted the cloud of these variables for precipitation, soil moisture, snow, and runoff, along with the somewhat smooth version of the HADGEM simulation, which is shown by the red traces here. So what you notice is that precipitation, of course, is low because we constructed it that way. We selected this one. Within the period of the drought, again, on average, it's a little less than 80% of the historical median. It varies interannually and so on, just as presumably nature would. Temperature increases through the period as expected. In this particular model simulation, it increases a little more than the overall mean, but part of that is because the land surface is drying and there's feedback, which presumably makes the atmosphere warmer. Soil moisture declines rather steadily through the simulation, presumably the result not only of the precipitation but also the cumulative effects of water demand by the atmosphere as we go forward. Snow also declines. It fluctuates, but in general declines through the period. And then finally, runoff declines as well, pretty much mimicking precipitation, but the precipitation results in a 78% of median level. The runoff is only about 65%. So a lot of the precipitation that's falling is used consumptively by the atmosphere or by vegetation in essentially robbing the amount that would normally run off. I should say that in this drought scenario, we also carried along the previous several years of the dryness just to look at the evolution of drought. And actually, in the scenario provided to the teams, we also provided the years after so they could look at the adjustment out of the drought. On that note, all the variables recover to essentially the 10-year model envelope median as the dry spell is fading. But again, soil moisture and snow, two of the kind of storage measures of the hydrologic system, decline through the episode. And it's noteworthy that the impacts of the precipitation deficit are essentially amplified by warmer temperatures. And should a dry spell like this occur later on in the century, the results of even warmer temperature would be even more extreme. So for those that are interested, that dry scenario is available from the CalAdapt website, which is maintained up in Berkeley. And if you need more information, you can always drop me a note. I think I already highlighted the conclusions, so for the sake of time, I think I'll pass back to Amanda. Thank you.
All right, thanks, Dan. At this time, I'm going to give you some time to enter in some questions. We already have a few already. But while he's doing that, I just want to remind everyone these slides will be up on drought.gov later this week. And our next webinar is Monday, September 25th. Let's go to the questions. All right. Okay, so the first question is on the groundwater presentation, so for Jordan, do you have data that shows passive versus active groundwater recharge efforts? IOW locations that have natural recharge, e.g. streams beds, versus where water was diverted to provide recharge, such as a flooding of field or orchard?
Okay, so this is Jordan again. So that's a very good question. Unfortunately, slightly outside my purview, but if you would be willing to either send me an email or through Amanda, I do know where to go to get this information. So some of our partners that we're working with at USGS are pretty well in tuned with those types of efforts for targeted groundwater recharge, and I'd be happy to follow up.
And then we have one more groundwater question. Are there any measures of groundwater-related subsidence and long-term impact on aquifer capacity from the drought?
So another very good question. This one, so there are a couple of ways you can look at ground subsidence. You can actually measure this from space using remote sensing technologies. There's something called synthetic aperture radar, where NASA JPL has put out images showing pretty distinct depressions, particularly in the sort of southern Central Valley near Corcoran, I believe. So you can see how much the ground is actually sinking as you pump water out of these aquifers. And in terms of long-term impact, the other way of looking at subsidence is through modeling. And so this is another area where we're working with USGS, who've developed a comprehensive water balance model for the Central Valley in particular. And one of the outputs from this model is, in addition to groundwater pumping and elevation, is land subsidence. So you can actually track this through time. And one of our goals is actually to work with them to develop a tool to bring these estimates online so that folks can go and look each month at updated maps of groundwater as well as land subsidence.
Okay. Thanks, Jordan. I don't see any other questions. Again, I just want to say thank you everyone for joining us and thank you for our presenters today. Please contact us if you have any more questions or follow-up information, or if you want to hear more about the California Nevada DEWS or become more involved, such as with this webinar, let us know. Please fill out the post-webinar survey. We're doing currently a review how we did in the last year, and we've been using those to keep up with timely topics that you guys have been asking for to present on at these. Otherwise, we'll see you next time in September. Thank you.